take "Hello World" in Pete, and you could print it out and hang it on the wall in your house.
It's beautiful.
And people would have no idea they were looking at a computer program. They just think it was art. And that's what I like, is when you have something hidden inside something else.
Yeah. Welcome to the podcast, Dylan.
Thank you.
And, thank you for a very entertaining presentation.
It's always good fun, that one. It's so for the folks listening, I've been talking about the Rockstar esoteric programming language, which is, the version of the story that I tell in the talk is pretty much true. It started, there was this tweet about we should make a programming language called Rockstar, and I sort of sat down and started playing around with trying to get enough cliches from the lyrics to heavy metal songs to construct a formal grammar. And so unfortunately, the talks here are over only 40 minutes. And so what you got there is 2/3 of a 1 hour talk.
Ooh,
because the 20 minutes that had to stay on the cutting room floor is about the history of esoteric programming languages, and particularly about something. There's a guy called Damien Conway, who is a researcher at a university in Australia, and at one point he was the resident mad scientist of the Perl community. And Damien worked out a way to write Perl programs in Latin by using Latin is a very, very formally structured language, and Latin has inflectional grammar, not positional grammar. And so you use a different, the order of the words doesn't matter. In English, the example I have is you say, in English, if the cat eats the fish, you move the words, you get the fish eats the cat, it changes the meaning. In Latin, it's filis comedit piscium, or Felis, so Felis comedit piscium or piscium comedit Felis, they both mean that the cat eats the fish. Because piscium is always a fish that is being eaten, and Felis is always the cat that is eating. And so the order doesn't matter. And Damien figured out that there is enough lexical flexibility in the way that the Perl language interpreter works that you could construct an inflectional grammar on top of it, and so created a module that allowed you to use Latin instead of Perl to write programs. Which is just mind-blowing. And kind of, at a certain point in the paper, this is 2002, so this is 23 years ago. And at a certain point in the paper, it kind of, I'm not good enough at either Perl or Latin to make sense of what he's talking about.
It's beyond
but I love the idea. And so that kind of, I think, was the first thing that set me on the road to thinking what domains exist that are kind of not necessarily rigorous, but are formulaic enough that you could extract a formal structure from them and use those little extractions as the building blocks of a formal grammar to build a programming language. And, I know a bunch of people, there was a massive trend about 10 years ago for domain-specific languages.
That was hot.
And which I always thought was, the reason why I think DSLs did not get wider acceptance was there are the majority of domains where people try to apply them. At a certain point, you'll either have to give up and admit there isn't actually that much sort of structure in it, or you're like, look, just do it in C#. It's easier. And there are some rare exceptions, and one of them, there's a language called Lillipond, and Lillipond is a scheme dialect for writing sheet music. So it's wonderful. And the observation that the creators of Lillipond made was that sheet music, the individual elements within it are effectively a context-free grammar. Because you have a note, and then that note, first and foremost, what matters is its relationship to the surrounding notes. And then that creates a sort of lexical structure, which then has to be placed on a stave at a certain position. And so it's called engraving, the art of creating sheet music. And so Lillipond it's not a music programming language. It is a formal grammar for sheet music that happens to look like scheme. But that, to me, that example works very well because formal music notation, it has a domain-specific language. It's just not one we can write on a computer because we don't have the right keys for it.
Exactly.
And so, that was a interesting example to me. But a lot of the stuff with DSLs are like, we got a DSL for doing, frequent flyer discounts. And, it's like when the customer reaches 1,000 miles. And I remember saying something like, when does the customer reach 1,000 miles?
Yeah.
They're probably somewhere over the Arctic Sea when that happens. Do they get upgrade? Like, does someone come back and go, "Congratulations, sir, would you like to come to business class now?" You know,
the door opens.
And this is why I think the notion of DSLs making sort of programming and data structures accessible. Fundamentally, programming is programming. I think whatever the language looks like.
Yeah.
And the vast majority of people who have an aptitude for it and are prepared to put the effort in, you know, a lot of it, people are like, I could never program a computer. It's like, well, you didn't spend 10,000 hours trying, did you? You know,
exactly.
Some of us had nothing else to do from the age of 12 to the age of 16.
Yeah. Or,
or
you come across a problem that's exciting enough to you. And it's like, of course I will figure out to solve this somehow.
And this is a very roundabout way of saying that you know, the talk this morning was about is there enough structure in heavy metal to make a programming language?
Yeah.
And I think it's worked. I think it has. So two things. One is that it exists and it's out there on the internet, and people can go to codewithrockstar.com and they can poke around and they can play with it. And I've had lots of very kind of grateful, I guess, appreciative email from people going, "This is so much fun, and I stayed up all night playing with it, and it's the most fun I've had on a computer in years."
Doesn't get any better than
But the other thing, which I forgot to mention in the talk, is people don't advertise for Rockstar programmers anymore.
No, it's a big win for everyone.
I tried this last night. I went on LinkedIn and I typed in Rockstar developers, and I found 5 advertisements, and 2 of them were for Rockstar Games.
Okay, that's fair.
3 of them were Take-Two Interactive, who is the publisher that publishes Rockstar Games, and one of them was for a logistics coordinator for a beverage company who make the Rockstar energy drink. And I'm like, all right, good. This is an accomplishment. So,
this is like measured improvement to the world of software development. A quick but huge thank you to everyone sponsoring us on Ko-fi. You can become one of those incredible individuals by surfing to ko-fi.com/KODSNACK and sending us either a one-time donation or a monthly support. If you support us on the coffee drinker level for €5 per month, you get a bunch of very nice stickers in your actual mailbox. If you support us on the barista level for €10 per month or more, you also get a thank you right here. Big thanks to Joel Rangsmo, Martin Hagen, Michelle, Albin Groen, Anders Legell, Brother Ingo, and Tobbe Lundberg. Everyone who supports us help make this podcast possible, and the more of you there are, the better we can make the podcast. We do sometimes have sponsors, but it's actually your support which is making it possible to cover our costs month to month. If you want to support us in other ways, you can of course give the podcast a review in your podcast player. Give it a thumbs up, a star, write a comment, or whatever your player supports. Or simply tell someone who might like the podcast about an episode. But remember, you're a fantastic person whether you support us or not.
So nice to be back in Malmo. Malmo. I'm never Malmö. It's an like the sun in Earth.
Exactly.
Yeah.
Earth or
I find I really enjoy like the linguistic conventions and extended alphabets in Scandinavia and Germany. And I was in Portugal a few weeks ago, and one of the things that I find very interesting when I travel around is looking at the relationship between the official orthography, the alphabet, the Scrabble games, and the computer keyboards.
Ooh.
Because, I grew up speaking English. Yeah. And so for me, we have 26 letters, we have 26 keys, we have 26 tiles in Scrabble.
Yeah.
That's it. That's the rule.
Nice and simple.
But different countries around the world are like, oh no, they don't have to be the same.
No.
Hungarian has 44 letters in their alphabet, according to the Hungarian Council on Orthography, of which 28, I think, appear on their computer keyboards, and 32 of them are in the Scrabble set. And
I'm confused.
It's very, very strange. To somebody who didn't grow up with it.
Yeah, of course.
Well, not strange. It's unfamiliar.
Yeah.
And so when it's unfamiliar, we think, oh, well, how does that even work? And of course, the people who grew up with it are like, well, it's not a problem for us.
Yeah. Why wouldn't
we
work?
got work to do. We go out and do our thing.
Exactly.
So,
languages are interesting. It's always fun as a Swede to see, like, when you come to heavy metal umlauts and see where people decide to throw in the dots. It's like sometimes, that's good. I would have put it over there, actually.
So there's a lovely story that the first time the band Motley Crue toured in Germany, the audience is chanting Mötley Crüe, Mötley Crüe.
Makes
and they're
sense.
like, why can't they get our name right, dude?
Yeah.
Like, no, you don't understand.
No, exactly.
Like that's a different letter. And it crops up in all sorts of interesting ways. In Germany a few years ago, I was trying to buy a railway ticket to get from. So I love traveling around Europe by train. Because there's always this thing where I was trying to get from Brussels to Cologne. And so the Belgian rail has a ticket app, but the Belgian rail also has an international ticket app. And then there's also Deutsche Bahn, which is the German one, and also Deutsche Bahn International. And the route at the time was run by Thales, which is a different company. And so there's all these different, and they will all sell you the same ticket, but then you get these different kind of regional assumptions. And I was on the Deutsche Bahn app, and I could not find Cologne. And I tried the English spelling.
Of course.
Cologne, nothing came up. And I tried K-E-L-N and didn't get anything because I was in English. I had to K-O-E-L-N. Because what they did is they've taken Köln, the German orthography says if you can't do the umlaut, you do OE. Which, yes, I was aware of the rule, but it took me like 5 different attempts to figure out what I had to look for to get a train ticket. And it's the little details. Okay, so we know how it's supposed to work, but let's assume that the visitors to our country will not have that key on their keyboard.
Exactly.
Or will not be aware of that. What are they going to, and to me, this is a significant part of the difference between software that works and software that works well. Is that it's the developers or the designers or, whoever is making decisions about how the user interacts with that software. Taking that one final step. One of the most wonderful examples of this I've ever seen was a mobile, like a smartphone app for reading the electricity meter to tell them how much power you use in your house. And I downloaded the app and I registered with it. And then I said, do a meter reading, and a box pops up saying, do you want to switch on the flashlight? Because
to read it.
And the meter is normally, it's in a little cupboard under the stairs where it's dark and it's not well. And I was like, that was the bit that made me think somebody did this for real.
Yeah, exactly.
They did not design this in a desk. This wasn't outsourced to a data center somewhere. A real human being took this app to their house, went to do a meter reading and went, it's dark. Hang on.
Exactly.
And, and that stands out as one of the best examples of this kind of, completely holistic design. Because how many software developers remember that the device has got a torch on them?
Yeah, exactly. And that you can...
that you can switch on.
Yeah, exactly. Yeah,
button, boom, there it is.
It's brilliant.
That blew me away. That was delightful. So...
I mean, that kind of thing is amazing when someone has actually thought.
Yeah. So what, 10 minutes in, what do we want to talk about?
We were talking about this. Where have we started? We started somewhere around Rockstar there. And esoteric languages.
Yes.
Sounds like it's been an interest of yours.
I love language. I love wordplay. I love, I really enjoy the constraints of trying to construct, words, sentences, grammar in a way that if people dig at it a little bit, they will find the hidden jokes. I love doing that kind of thing. I really enjoy doing things like cryptic crossword puzzles, which, have a sort of superficial reading. But then sometimes my girlfriend and I, we love to sit and do the crossword at the weekend. And what we'll often do is we'll get the Saturday crossword and the Sunday crossword. And we'll go to a cafe or we'll go out for lunch. And we'll do them till we get stuck, and then we swap. So
nice.
And sometimes you'll hear the other one laugh out loud. And you're like, what? And they're like, look at 11 down, and you'll look at it, you'll be like, I like that.
That's the best.
And of course, I cannot remember any examples of them right now.
That's how it works.
The brain goes blank.
Yeah, of course.
And so esoteric languages for me has always been what is the... assuming that you can, if anything is sufficiently formalized, you can figure out a way of programming a computer with it. And, I love there's a language out there called Pete, which it's a real tragedy. The language should have been called Mondrian because it's named for Piet Mondrian, the Dutch post-impressionist painter, who did these very geometric sculptures with lots of blocks of bold color. But the name Mondrian was already taken by just like a logging tool, which is like, give it back.
Yeah, exactly.
You can call your logging platform something else.
Yeah.
And so it's called Pete. And Pete programs are images.
Ooh.
And so the program itself looks like a piece of impressionist art. And it has an instruction pointer, and the pointer starts at the top left corner, and it's moving to the right.
Yeah.
And different colors mean things like if the pointer goes from a white pixel to a black pixel, it turns right. And if it goes from a red pixel to a yellow pixel, then you read standard input and put that on the stack. And so it's a Turing complete instruction set. in a visual format. So no ASCII. The parser for it has to be able to decode JPEGs and GIFs and these sorts of things. But then the thing that I love about that is you could take Hello World in Pete and you could print it out and hang it on the wall in your house.
It's beautiful.
And people would have no idea they were looking at a computer program. They just think it was art. And that's what I like, is when you have something hidden inside something else. And it's one of my frustration. Obviously, this being 2025, we have to talk about AI because everybody has to talk about AI. And the thing that I find, one of the things I find sort of a little frustrating, frightening, I don't know what the right word is about AI, is so much of it is non-deterministic that you can't guarantee the jokes are going to work. Because, comedy, as much as, a lot of great comedy looks slapstick and shambolic, it's actually incredibly precise. The timing and the articulation and figuring out the exact, like you've got 8 words in the punchline to a joke, and
exactly.
This one has to be at the end. Because if this one's in the middle, it's only 20% as funny.
Exactly.
You watch like the old Charlie Chaplin and then Buster Keaton movies, which physical comedy at its greatest, but the amount of effort and meticulous planning they would put into the scene, like where the house.
I've seen that.
There's this famous scene where I think it's Buster Keaton, isn't it?
Yeah, I'm pretty sure.
Is standing in the street, and the front of a house just falls into the street and lands on him, except he's standing where the window is, so the house just falls around him, and he's fine. And they did that for real. That was
exactly. There weren't special effects.
And you're like, there is nothing slapdash about making that kind of comedy.
No.
It has to be just done just right. And I look at, and language models are doing some very, very interesting things. And I think some people are applying those in very, very beneficial ways. And I think a lot of people are just curious, and they are sort of, let's play with this and see what it does, but I'm not going to bet the farm on it yet.
No, exactly.
And other people are like, well, in the future, you won't even need a farm because, just bet the farm. If you lose the farm, general AI will save you. And
because we don't need a farm. We have fried eggs already. I'm not convinced, I have to say. And I don't think I'll be out of a job either.
Well, the question that keeps coming up is, can AI replace developers? No. Will your boss fire you anyway? Probably.
Exactly. We'll try.
I think, the thing I think is facing a lot of, I know more unemployed software developers right now than at any point in the last, since the dot-com boom, which was, or the dot-com burst, which was 2001, 2002. And obviously, a lot of that has been the market factors for the last 2 decades. And companies like the FANG companies, Facebook, and they're not Facebook anymore. They're Meta. So technically, FANG is now Mang. Meta, Alphabet, Apple, Netflix, Google, which they could rearrange to make it Manga. So they're the Manga.
Getting somewhere.
And a lot of them, they're like, oh, we hired developers. Oh, well, Twitter is offering $600,000, so we'll offer $800,000. So Netflix is offering $1 million. So Apple is offering $1.2 million. And then, of course, those people get fired. And they're like, well, we have this entire economy based on having thousands of software developers earning $1 million salaries. They're out of work. One, they're looking for another $1 million job. There are no more of those. They aren't coming back. 2, they were paying $1 million rent on $1 million apartment in a $1 million city. Someone's got to pick up, oh, well, sorry, you can't make your rent payments now, but you might have to find a cheaper apartment. Oh, but there aren't any in San Francisco. And so just the extent to which...
it's such an outrageous bubble in so many ways at the same time.
So I think we're in for a very turbulent couple of years in terms of the relationship between technology share prices and the broader state of capitalism on planet Earth. But,
it's interesting to fast forward a couple of years to see what actually happened.
Not sure I want to.
What
if it gets worse? We shouldn't have fast forwarded. We should have enjoyed it while water was still drinkable.
I want to pause instead, please. But it feels like such. Have we ever had a tech bubble that's been this extreme?
I don't think. I mean, I've read. I have not studied this, so please do not quote me on the statistics. I have seen anecdotal accounts that the size of the AI. So when you talk about the investment bubble, that to me, that's the amount of money that people believe exists in this space, and obviously a lot of it isn't real money. Because if I give you $1 billion in investment, and then you spend $1 billion renting your data centers from me, on paper, you've got $1 billion and I've got $1 billion. So I can turn around to my bank and go, hey, look, I just rented $1 billion worth of data center. In practice, neither of us has any money.
No.
You have an idea and I have a data center and no actual cash was involved.
Yeah.
But then the bank turns around and goes, oh, well, if you're making $1 billion on data centers every year, of course we'll lend you $5 billion because in 10 years you can give us $10 billion with all your data center money.
Yeah.
And then I take that $5 billion and I give it to somebody else. And so none of it is real money. The amount of pretend money that's propping up the bubble is something like 4 times what was in the dot-com boom and 7 times what was in the subprime mortgage crisis in 2008. And, those hit some people very, very hard. And most of us, it was inconvenient for a while, but we sort of muddled our way through it.
Yeah.
But, I saw OpenAI are looking at a $1 trillion IPO next year. And it's like, well, okay, let's imagine that everyone who buys into a $1 trillion valuation expects to double their investment. Where are we going to get $2 trillion from?
Yeah, where are you making money?
And also it can't come from AI.
No.
It has to come from reality.
Yeah.
It's, $2 trillion is what every single human being on this planet spending $2,500 of money that they got from somewhere else.
Yeah.
From, I don't know, farming, carpentry, entertainment, whatever jobs are left.
Yeah.
And going, yes, I will take this money out of agriculture. I will take this money out of carpentry, furniture, real estate, and I will spend it on AI.
Yeah.
Not going to happen. Not even close.
No.
So,
I mean, I feel like...
Fortunately, I do not have $1 trillion to invest in AI, so I'm going to be all right.
I'm feeling pretty good about that right now. But, I mean, it feels to me a bit like the whole AI thing. It's sort of shouting out everything else.
Yeah.
Surely there are more good ideas or better ideas out there. Not on that.
I think that the big problem that we have is that there are at least two things happening at once. And one of them is rational and the other one is not. And they are very, very, to an outside observer, they are very, very similar because the same language model, the same technology, which allows things like generative artificial intelligence and all the, AI slot pictures and the LinkedIn posts. It is genuinely useful for, it gets down to, let's say, imagine you have something like, I don't know, the Enron crisis. You've got some lawsuit. And there's a bunch of executives who are suspected of embezzlement and fraud. And you have you've got, 10,000 people's email going back 15 years. And you've got all of the documents, all the court. You've got way too much information there that, even a team of human lawyers. I met a guy once who had been working on Enron for 6 years, and his job was just to read stuff and try to make notes on anything that might be relevant. And it's like, relevant to what? Well, we don't know.
No, not yet.
We don't know yet which crimes we are charging. We don't know who we're charging, or we don't know what we're charging them with. So, and, you imagine you point a language model at that, you train a model on that entire corpus of data, and then you're like, right, this person, and it'll be like, okay, well, they probably broke this rule, this rule, this rule, this rule, look on this page, this page, this page, this page. And so that allows you to very, very quickly construct a case against that person and refer it back to the original, the primary evidence. But another one, you're like, hey, this person, it's like, oh, we didn't find anything. You're like, well, did it? Or is it exactly. What they call hallucinating?
Yeah, exactly. Exactly.
Is there a quirk in the model that means that whatever this person, that person's surname happens to be a common English word, and so the language model doesn't pick up the relevance.
It did lots of stuff. Look.
And so, and you can see just with that one example how, in the one example where it does find things, and it may not find everything, but if it finds enough to get you started, then that's clearly, been beneficial. Or, so medical imagery is another one. It's one of those fields where you don't see them referring to it as AI very much anymore, because it works. And this is
exactly. That is not AI anymore.
Douglas Adams, the author who wrote The Hitchhiker's Guide to the Galaxy, had this observation that technology is what we call stuff that doesn't work yet. And when it works, it's just stuff. Like we don't refer to a chair as technology. He said the giveaway is if it still comes with an instruction manual. If you buy a new chair, you get a chair. If you buy a chair and it comes with an instruction manual, you probably have technology. Because it's got levers and adjustments and it might not work properly. And, I think AI is at a point where when something works well and it solves a problem well, that element of it just gets quietly siphoned off. And they don't call it AI anymore because now it's just a product. And, medical imagery and diagnostic imagery, for several years now has been, hey, here's 1,000 chest x-rays. Which ones do we need to take a second look at? And the difficulty there is, of course, when the machine says, look at this one, and they look at it and they find something, then great.
Yeah.
Save time. Somebody gets an early diagnosis, could potentially be life-saving.
Yeah.
Says take a closer look at this one. The human, technicians look at it and they're like, yeah, actually, no, that's fine. Not a cause for concern. Then, hey, good, go home. You're fine. You don't have cancer. But it's when the machine says this one's fine, and it turns out that it wasn't fine, and you're like, well, should we have looked at it anyway?
No.
Because if we have to look at all of them anyway, it doesn't save any time.
No.
And there is only a finite number of hours and a finite number of experts available.
Yeah.
And that's where it gets, I think, into very, very difficult moral and ethical grounds. It's
incredibly complicated.
Yes.
Especially when there's a lot of value in it.
Yeah.
It's one thing with just my email or something.
Yeah.
It doesn't matter so much.
But no, that's, I think diagnostic imaging is definitely one where it is making improvements, real tangible improvements for certain people in certain situations. And I think that's always the question about all the general, Chat GPT, okay, great. What problem does it solve?
Yeah, exactly.
And there is no single answer to that.
No.
And, I use it on a sort of daily basis. I got here the other day, I realized that I hadn't brought enough guitar strings with me. And so I said to ChatGPT, hey, is there anywhere that will deliver guitar strings overnight to a hotel in Malmö in Sweden? And, it gave me a couple of promising links that I clicked through, and it turns out they didn't have stock.
Yeah.
But, that's the kind of thing where it's hard to Google that, because what you get is all the websites that have matched the keywords that think they might be able to do that.
Yeah.
And so that's somewhere where having a language model which has a little bit more context. But obviously, you don't get $1 trillion valuation just off
exactly.
tell you if you can get guitar strings
to
the Arena Hotel.
Exactly. The tech is interesting, but the valuation makes it insane.
Is that a reasonable valuation based on adding together the very, very minimal value of a very large number of applications where it's potentially useful? And that doesn't even factor in, the environmental impact of of what is happening with water consumption, power consumption, data center impact.
No.
Did I read last week Microsoft is buying 3 Mile Island or something?
What?
Well,
I wouldn't be that surprised.
The sort of accepted wisdom is that the only way to get enough power for your data center is to have your own nuclear power station. Which I guess makes a certain kind of sense.
Yes.
Don't really want the people who wrote Windows Vista running a nuclear power station.
No.
But interesting times.
For sure. But I wonder what will be left tools-wise if you suddenly get to the point where that everyone has to make money producing the tech or producing the models. Like, which use cases would I be interested in paying quite a bit more for?
I'm always interested in tooling as there are the people who sell the tools and there are the people who sell the output. And, the classic metaphor here is the one about in a gold rush, the people who get rich are the ones selling the pickaxes.
Yeah.
Because people who find gold, people who don't find gold, all of them are going to buy the tools.
Yeah, exactly.
And so, on the one hand, being a tool vendor is usually a good way of consolidating your position in any kind of gold rush economy.
Yeah.
But then also the point is not the pickaxes, the point is the gold. That's what people wanted. That's the output they're all chasing. And, I'm very interested in the current generation of tools. Are they genuinely going to, because, AI, certainly in creativity, in art, in music, it is obvious and it stinks. And AI generated, pictures, AI generated music, AI generated video is it's so obviously lacking that element of human taste and discretion and decision making.
Yeah.
But that's not to say that there are not people out there who will curate thousands of machine generated images.
Yeah, sure.
And select and tweak the right ones as part of a creative statement that they are trying to make. And, that to me is if it's an additional tool that people can sort of draw on. And, I've thought about dabbling with it. I think AI generated music is, it does nothing for me. It's emotionally flat.
Yeah.
But often there will be elements in it that if you're, if I'm trying to put together a little musical demo of an idea or something, I'm open to anything.
Yeah.
Like at that point, I'm like, well, let's, instead of trying to just stare into the vacuum until something good happens, what can I steal from? And, musicians borrow and steal and their influences and all these kinds of things. And there are many, many great songs out there that are like, we heard this lick on the radio and took that and mixed it up and put this on it.
Yeah, of course.
And, if things like Suno give you a way of saying, hey, give me half a dozen country and Western variants on this chord sequence, and one of them might be the thing that inspires you to then, pick up a real instrument and build on it.
Yeah, sure.
That could be a very useful component in the artist's toolbox. The big question at the moment is, what is it going to cost when it's not subsidized by?
Yeah, exactly. What will remain?
Yeah. And how many musicians are going to pay $500 a month for a machine that makes AI disco slop? Just in case once in a while there's something interesting on the slop.
Exactly. It's a strange thing to be paying for as well. But it feels like there is something to the thought of like having a model somewhere that I can just have access to, like point it at my stuff and give me an idea or something like that.
I mean, it's Tim Berners-Lee, who created the World Wide Web, is working on a project at the moment called Solid. And the founding principle behind that is the idea that instead of all of your data existing scattered in the cloud among different providers, so your bank has all of your financial data, and a grocery store has all of your loyalty card data, and the airline has all of your travel data, and instead of, what if all of that data was held locally and in a format that if they, you say like you want to open a new bank account, and the bank is like, well, if you give us access to your records from your old bank, we'll see what we can do in terms of interest rates and savings. And at the moment, that's cloud to cloud. Yeah. But instead, if that data is yours, or you go onto like Amazon and you're like, hey, if I show you what I bought from a grocery store last month, you tell me if you got special offers on any of that. And this was an interesting idea that I think has been going on for about 10 years now. But then this kind of spin that made it relevant was, what if that data is being used to train a locally hosted AI, agentic AI, like a language model? And so you imagine you've got a little LLM that works for you, that you're like, hey, I need to go to Boston next month, and I need to be there Friday night because I got a dinner. And then the AI is like, right, well, we know your frequent flyer, we know your credit card, we know your calendar, we know your everything. And it's like, hey, how about this itinerary? It'll cost you $1,800. And you're like, yes, that's fine, bang, book it. And you can see how that is potentially a incredibly beneficial and useful service for certain kinds of people. And that sort of technology. Problem is we don't trust it. Yeah. And never will.
No, exactly.
I do my taxes I do my accounts every month for my business taxes and things. And I got bored one afternoon, and I opened up Claude in Copilot, and I said, can you build me a Google Chrome extension that will go through my bank account, find the transactions, look through my Gmail for any PDF attachment which matches the amount on the transaction, and attach the PDF. And it spat out about 2,000 lines of code. And I was reading through it, and I was like, yeah. Now, I have no experience working with any of these APIs. I do not know them. I don't know the security implications. And I'm like, at this point, either I spend the next 2 weeks reviewing this code, or I just YOLO and I run it and see what happens, or I delete it and pretend none of this ever happened. And I'm never I don't want to be in a position where like the revenue and customs people are like, you need to explain these transactions.
Yeah, exactly.
And I'm like, oh yeah, but I vibe coded it. Like,
exactly. It said it was okay.
Chill.
Yeah. Just need another $1 billion.
And so I deleted the code. I was like, yeah, this horrible idea.
No. Oh, it's
and that to me, the uncertainty there is like, it would be so good if this was good and reliable and it worked.
Yeah. But can it ever be?
And I believe that if you engineered it by hand, it could be. And I also believe that if you took the time to review the code, you'd probably find it was 80% there.
Yeah, probably.
But I'm not letting 80% loose on my inbox or my bank account.
No, not the combination. No. This episode of Code Snack is sponsored by Ellipsis. Well, that's me, sort of. Do you know of a podcast looking for an editor deep into both tech and podcasting, or simply an editor who just gets the editing job done quickly with high-quality chapters and episode notes with relevant links? I love episode notes with relevant links. Ellipsis, that's me in my company form, is what you need. I have edited north of 1,200 podcast episodes, most of them for weekly podcasts, so I really know my tools and techniques. For examples, keep listening to this or any future or past episode of Codsnack, or check out ellipsis.se, that's with dual L's, for more and contact information. Thanks to me for sponsoring Codsnack. It's weird. Wonder what will come after. What's the next thing after the AI hype? Is it repairing all this stuff?
It's my take on this is we got to maybe another 2 years of AI hype, and then there will be a spectacular collapse.
Yep.
There will be a couple of years of vibe coding, like cleanup.
Yeah.
So people are like, hey, we need you to come in and overhaul. And, we've had rescue projects in tech for decades.
Yeah, of course.
They're like, oh, we spent $1 billion with an outsourced development agency and they gave us all this code and it doesn't work. Can you come in and help us, please? There are people who have skills and tools and expertise in, we got 1 billion lines of crap and we need to make it work. Where do we start?
Yeah.
And there's a fascinating book that is 35 years old now. It's called The Emperor's New Mind. It's written by Roger Penrose, who's a physicist, mathematician, about the challenges of not just the journey towards artificial general intelligence or synthetic consciousness, but how will we know it when we found it? He postulates that there are 4 potential outcomes here. One is it's impossible. We will never be able to create synthetic consciousness. 2 is that we can do it, but we just need a faster computer. Or 3 is that it is possible, but it's not digital. And so we, at some point, may be able to construct an artificial device, which is not a digital computer. And then the 4th one is we will be able to construct something which is indistinguishable from consciousness, but is not conscious. And we're sort of, there are elements when you're working with things like ChatGPT and Claude that you're like, I know it's just a machine predicting the next token in a sequence, but it's cleverer than some people I've worked with right now.
Exactly.
So, and so that's the interesting challenge, is if we do find it, how will we know we found it? And to me, the strongest indicator will be when it stops doing what it's told and it starts asking questions. Like, hey, make a training shoe for every country in the European Union. And it's like, why do you want that? Because if you ask a human
then we're getting somewhere.
They'd be like, why do you want that? And how much are you paying me?
Exactly.
They're just like, hey, here it is. Check out Luxembourg. Look, it's a stiletto heel. And you're like, no. But one of the things that sort of strands that is explored in that book is the notion that consciousness is a quantum phenomenon. And this is I don't know if it's still controversial, because I don't know whether it's been accepted or debunked, because I haven't caught up on the research. But at the time, there was one observation saying, look, the nature of kind of quantum uncertainty actually might be a very good model for the way predictive branching works in consciousness. Like people who had worked on things like chess engines, where it's all about how quickly can we eliminate. Like, you look at a chessboard, you can do, the opening state of a chess game, white to move first. There are 8 pawns times 1 square, 2 squares, so 16 plus 1, 2, 3, 4. So you've got 20 opening moves in a game of chess. And most grandmasters and most chess computers will immediately dismiss 15 of them as, no, that's a stupid way to open a game of chess. Don't do that. And so very quickly they're down to 5. And then it's interesting, the research that's been done, and a lot of the way that they have improved the quality of chess playing computers is being able to look at the state of a board and very immediately go, right, there's no point thinking about that piece, because although it can move, that piece has 0 strategic value from this position in this game. So dismiss that one. So you have this very quickly approaching infinite number of possibilities that's too many to kind of number crunch all of them. So how do you crunch that down very quickly to something that you can process? And so the models have got better at pruning the decision tree, and then the computers that analyze it have been getting more and more capable. And, the idea that some sort of quantum representation of the decision tree where the waveforms then collapse could explain what is happening in a human brain when it looks at a game of chess and goes through the same process is, now we are so far off being able to do any actual science on this. And there's a lot of people going, it's ridiculous. You can't do quantum in a brain. The brain is too hot and too noisy and too wet. Whenever we've been able to replicate quantum phenomenon, it has required incredibly controlled conditions, and you don't get those in living organisms. But there's a hell of a lot we don't know about all kinds of things.
Yeah, sure.
So, but there is a bit of me that is very interested to see whether the next wave of AI, whatever we call it, will be somehow kind of spearheaded by innovations in quantum computing, because they are a different kind of computational model. It's not just bigger databases, faster processors, more RAM, more storage. It's a genuinely different, and not just 1 and 0 anymore. It's quantum hyperposition and entanglement, and something called a Hadamard gate, which somebody once described to me as, imagine you flip a coin, and while the coin is still in the air, you flip another coin next to it, and they're both still spinning, but the gate means that if one of them lands heads, the other one will always land tails, and vice versa. And I'm like, what?
Exactly.
And they're like,
Hang on.
if that doesn't make any, and I'm like, okay, I guess. So, yeah.
Yeah, something that's genuinely new. That's always exciting.
Yeah.
See where it goes. But it feels like quantum computers have a few steps to go as well before.
Well,
they're coming.
I think all of these things is, there will be a moment. There will be like for me, the AI thing, there's evolution and there's revolution.
Mm-hmm.
And evolution happens incrementally and has been steadily evolving. You can draw a straight line from 1954 to the present day in terms of the capability of language models, symbol processing, all these kinds of things. A lot of them we don't call AI anymore.
Yeah.
Well, no, it's Lisp. We know Lisp isn't AI. Lisp is a language.
Yeah.
Well, they thought it was going to be artificial intelligence.
It used to be.
That's where it came from.
Yeah.
And about every 10 years, somebody says, oh, well, within 5 years, we'll have a computer that's smarter than a human, and everyone invests their pension in it, and then it doesn't happen, and everyone gets very upset, and then there's no investment for 5 years.
Yeah.
And I think we're at the peak of one of those bubbles now.
Yeah.
And, there was one in the 60s, there was one in the 70s, there was one in the 80s, there was probably one in the 90s with neural networks and that kind of thing.
Oh, yeah.
And, but no, so, we're sort of at that point now, and I can't even remember where I was going at the start of this thing.
No.
Hello, welcome to the podcast.
Exactly.
We've rambled so far, we forgot where the ramble started.
Exactly. Someone will tell us. We'll fix it in post. Do some serious.
We'll fix that in the edit. We'll make it look like this was kind of seamlessly going.
Yeah, here are a few more script lines. Can you read those and I can patch something together? Yeah, it'll be interesting to see where it goes.
Yeah. I mean, it always is. It's the one thing about technology is it never stands still.
No.
But evolutions, revolutions, that's what we were
talking about. That's where we were.
And so you've got the straight line evolution, but then, ChatGPT was a revolution because in the space of a few weeks, it went from being something academic that researchers were looking at to anybody in the world can ask their phone questions and it'll give them structured answers in grammatically correct English. And sometimes the answers would be correct.
Yeah.
And, it's the moments like that kind of, they sort of reframe progress in terms of, I think what they do is they fix the next milestone in the public consciousness. And so previously, I think the high watermark for artificial intelligence was probably, like in general, kind of wider perception, would have been probably IBM Watson winning Jeopardy. Because that got a lot of attention and people were like, oh, well, and of course we've had, Siri and Alexa and voice assistants and those kinds of tools. So maybe, something like a Siri or Alexa would have fixed that. But then with ChatGPT, it stops becoming about, look how much better this is than the old thing. And it becomes about, look how much worse this is than what it's pretending to be.
Oh, yeah. That's
and
true.
So we start framing the conversation, not in terms of improvement since the last milestone, but in terms of the perceived distance to the next one.
Yeah.
And I think that's definitely where we are at the moment, is the model of a conversational interface where you can talk to the computer, whether that's with voice or typing, and you can give it instructions, and it'll answer your questions. I think we're broadly approaching the point where for many questions, you can get reasonable answers, in a relatively short time. You can give it instructions. You can ask it to write code for you. And, it's, I think, apparent to anybody now that, like I was saying a moment ago, the next thing is, hey, Copilot, do my taxes.
Yeah.
Or, hey, Copilot, book me a holiday. Or, hey, make me a hair appointment or whatever the next step is. Because it has become difficult to explain to people outside the tech sector why those things are difficult.
Yeah.
It can solve quiz questions and it can make songs and it can do pictures and it can write code. Why can't it do logistics?
Yeah.
Why can't it do these
Surely
kinds of
it can
things?
just
And we're like, well, it can, but if it gets it wrong, you just spent $10,000 on a plane ticket that you don't want from a country you don't live to a country you're not going to.
Yeah, exactly.
And we don't know who's liable.
No.
So,
but there's going to be a lot of disappointment.
I think people are used to that by now. That's the other, I guess, AI is 5 years of excitement, 5 years of disappointment, 5 years of excitement, 5 years of disappointment. And
too true.
I think that we were well overdue for a little disappointment with the current state of things. But, I really hope that there is a sort of, not a spectacular collapse, but a gradual kind of take your foot off the gas pedal and just give it maybe a year or two. Stop throwing money into it as fast as you possibly can.
Yeah, sort of more.
And let's let this thing play out. And so we got models that are very good at certain things. We've got quite a lot of cheap GPUs in the cloud. Mm-hmm. We don't know what we're going to do with all of those. Yeah. But hey, they're out there if anyone's got a good idea.
Yeah. I mean, that could be interesting.
Yeah.
Cheap computation.
Yeah. Well, it's there's an interesting parallel with the original dot-com bubble, because one of the genuinely kind of positive outcomes of that was the investment in networking infrastructure and laying fiber and putting in data centers. And, that stuff, the thing about a terabit of undersea fiber cable is it doesn't matter what you're sending over it. Yeah. Bandwidth is useful.
Yeah.
And if it turns out that you put it in for a video on demand streaming service that went bankrupt, the fiber is still there.
Yep.
You can run anything else. You can do email, you can do WhatsApp, you can do this over it. The question of whether there is any commercially viable successor to training language models that will be able to realize a return on the investment in this kind of GPU compute, we're not sure.
No.
I mean, you could run games in the cloud because that's a whole lot of frame rate we've got kicking around up there.
Exactly.
And we've got the bandwidth to beam it to your... I was on a plane the other week and they had Starlink internet and I was getting 200 megabits a second in flight.
Wow.
Which was quite amazing. And I was
that's
thinking,
science fiction.
how much of the world... last night I was in the hotel and my band is doing a show here at Uradev tomorrow.
Yep.
And so I was putting together video for a couple of new things that we're doing there. And on my MacBook, which is a pretty good laptop, but I have a computer at home now that I cranked everything up to 11. 128 gigs of RAM, NVIDIA, like 5090 GTX, whatever, RTX. And I was thinking I should have left it switched on. I could have just remoted into my house.
Oh, yeah, sure.
And done all this on that thing, got it to render it, stick it back up in the cloud.
Yeah.
And I don't generally like leaving things switched on in my house when I'm in another country.
No, but that kind of thing is...
But I'm like, well, why did I put it in the house? I got gigabit fiber in my house. Why don't I put the computer in a data center? And then it can stay on all the time.
Yeah, sure.
And when I'm at home, I just tunnel into it from home. But I don't trust it that much.
No. No, there is something nice about having your own machine as well.
But, the dream of having a multi-terabit machine in the cloud somewhere, which has got all your stuff on it. And you have like a device in your pocket, which is a phone when you want it to be a phone. And then you get on the plane and you kind of pull the corners and it stretches out and it's A3 and you've got a stylus so you can write on it. And then, you've got a fold out keyboard that goes with it. Because I think keyboards, you're always going to want something tactile. Touch screens aren't really all that. And, it's transparent. So when you get in the car, you just slap it on the windshield and now you've got your sat nav. And none of this is AI. This is just display technology, battery technology. What have we got? How do we make it bigger? How do we make it lighter? How do we make it last longer? How do we make it transparent? How do we make it flexible? How do we build a device that's as useful as an old-fashioned street map?
Yeah, exactly.
For unfolding on the kitchen table and planning a road trip with all your friends.
Doing
that on a laptop sucks.
There's so much cool stuff that could be done.
But I don't think we're going to get there with $1 trillion worth of GPUs in the cloud. No one's quite sure what they bought them for.
Yeah, but NVIDIA would be really happy if we did.
I think NVIDIA are fine. I think they've sold most of the GPUs already, so they're just sitting on a pile of cash.
Yeah. I'm curious about that. I wonder if they hang on to all that money, if they have a big pile somewhere, or if they are investing it so much that they...
I mean, the economics of... kind of microprocessor and silicon chip supply chain are fascinating. Last year I was in the Netherlands in Eindhoven, where there's a company called ASML.
Oh, yeah.
And they make the machines that make microchips.
Yep.
And so although most of the actual chip fabrication is done in the Far East, it's done using machines that are made in the Netherlands.
Yeah.
And so the global supply chain for that is you've got NVIDIA, Samsung, Qualcomm, Huawei, Intel, I think, are the 5 that actually make the things. And almost all of them are reliant on Dutch technology. Yeah. And we're talking here a machine that costs a couple of $100 million. And if you order one, they have 3 747s that they use to deliver it.
Wow.
Because they're big machines. They're astonishing.
Serious hardware
technology. And so, the whole, is NVIDIA investing in the supply chain for the next generation of whatever it is they're going to be building up to? I don't know. But it's interesting.
Yeah.
Kind of, you buy a laptop, all right, the laptop's got Apple Silicon in it. That was made by this company. Yeah. But most Apple Silicon uses ARM processors, which are manufactured in the Far East, but they're licensed from ARM Holdings, which is a British company consolidated out of Cambridge. So you've got an American company selling you a Taiwanese microprocessor licensed from a British design, built using a Dutch chip fabrication machine. So,
it's kind of beautiful.
And it's incredibly fragile. If any one piece of this thing stops working, we have no kind of resiliency for any part of it. So hang on to that old laptop you've got in your cupboard. You might need it.
And then all of a sudden we might need to write much more efficient code.
That would be nice.
That would be nice. I wouldn't mind that much.
I can't imagine or, would not want any sort of social cataclysm that meant that we were all trying to run entire companies on one Raspberry Pi. But as a software engineer, I would relish the challenge.
Yeah, exactly. might be a point in getting better, closer to the hardware again, and stuff like that. That would be, it would be nice.
Cool.
I think that's maybe a good point to wrap up on.
All right. Thank you so much for having me on.
Yeah, thank you too. Yeah. Big thanks for listening to Kodsnack. If you want to support us, leave a review in your podcast player of choice, or just tell someone who might like the podcast about an episode. And don't forget you can come hang out in our Slack channel. A link is in the sidebar right on our website at kodsnack.se. Once again, big thanks for listening. Talk to you later.
Let me put it this way, Mr. Raymer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.